Okay. So let's go to the second part of the concept plan production. Okay, earlier we've managed to finish this concept plan, the one with the which are the columns, which are the framing, which are the beams, which are the slabs. Okay, so mainly it's on the floor layouts. Okay, now we will proceed with the conceptual sizing. Okay, so let's go back to our folder, SD1, then concept plan. There's, you notice there's an Excel here. Okay, so we already finished this step 3. We are now going to the step 4, the conceptual sizing. Okay, let's get to the slabs. Okay, so for the slab, this is not based on design already, but it's just a preliminary sizing. So first, we need to identify what material, what river grade are we using. So standard, we will use grade 60 for the slabs. And we will have two types of slab as we look at the framing. So let's review. So everybody will be familiarized. Okay, so these are the framings that we generated. So we have two types of slab. We have the hollow core, and then we have this blue one, which is the ordinary slab or one-way slab. We can tell it as one-way slab or two-way slab. Anyway, it will be one way. Then we can get here the sizes. Okay. So for the hollow core slab, so we will be using 320 mm thick because the span is 12 meters. We have the span of 12 meters. Okay. Grade 6 for 20, then the screed thickness will be around 75. Then total thickness of the slab will be 395, and then equivalent load 5.5 kPa. So okay, so this is accomplished. This is for the hollow core slabs. Then for the one-way slab, we can put here, so we can assume it is 12 by we can measure. Okay, so we can measure. Okay, so we can check if we are so this is the last that we calibrated, so we can check the distance here. Okay, so it's aligned. So you just need to check the distance. What will be the longest distance of our one-way slab? Okay, this will be a 6 by 5.4. This will be we have 6 by 5.4. We have 4.3 by 12. I think that's the two dominant slab. Okay, so we can use that as initial reference. We have 6 by 5.4. So let's try 6 and 5.4. What will be the thickness? The thickness will be 200. We will use a 4 point, the other one, 4.3 by 8, by 12, 4.3. So same. Okay. So let's use thickness is equal to 200. Okay. So we already have the size of the slab. So thickness 200, then the equivalent load will be 4.8 kPa self-load. So this should be 200 thick slab. 280. So 200 thick slab. Okay, so we can use a half slab there or anything once we go to the SD1. Then 320, 75. Okay, so let's modify. Second floor. Let's use 200. Okay, 280. Maybe those are very small spaces, so it won't affect that much in terms of cost. Okay. So we have now the slab sizes and our hollow core thickness is confirmed. Okay, so let's go to the next level, next step. We need to do the beams. We have two types of beams. We have girder and beam. So we can make it one size. Let's check if they have the same length. Same length, okay. So we have 12 meters span. So for uniformity purposes, let's put 12. Okay, so the approximate depth will be 1 meter for the 12 meter span. Okay, let's check another option. So check another option. So okay, so temporarily initially we can use 1 meter. So it will be 700 by 1 meter initially. Our sizes of girders. So we have the sizes of girders now. Okay, sizes of girders. So we have 700 by 1 meter girders and beams. Okay. Then for the columns, so we're only missing columns now. Let's say. Okay, by the way, these are the two options. One is the RBS option, this one, and then the C squared. Okay, they have a different style in doing the framing system. So since RBS was our usual partner, so we prefer to use RBS detailing. Okay, then column shear wall. So for the wall, we don't have shear wall, so we don't need to fill this one. Just delete everything, all the blue, so it won't create any confusion. Just delete that. And then let's start with this one. So we only have 3 floors, right? So we have roof, we have second, then we have ground, then foundation, right? So let's just make it the same. Okay. Okay, just put 0 here because the initial load will be 0. Okay, initial load will be 0. Okay, so let's start. For the area here that is governed by slab, so you need to select the column that we want to consider in terms of loading. In this case, so we can select this column. It will have a span of 12 by 12. So the slab area it's supporting is 12 by 12. Okay, so just put it 12 by 12. Okay, then the self weight, you can generate it here from here. So the self weight will be 5.5 kPa for the hollow core slab, right? It is supporting hollow core slab. Okay, so that one. It's like getting a tributary area. Tributary will be 6 here and then 6 here, 6 there, 6 there. So 6 plus 6, 12, and then 12 times 12, 140. Okay, let's go back to the column. So 5.5 is the self weight. Sorry. For the roof, we just assume it to have slab since we don't have loading for the roof itself. But once we did the SD1, we already start to calculate. Let's look the roof layout. Remember, we don't have slab here. Okay? So, but we have roofing, which is definitely lighter than our slab. So for the sake of calculation and initial sizing, we can assume that it is a concrete slab just to consider the loading. Okay? Now SDL and live load, so we need the load map. So let's open the load map. Load map. Okay. We can, since we all know, going back to the layout, we know that this column, the column that we considered, is supporting a locker slab, which is in retail area. So better we directly go to the Excel and then get the retail load. So it's 4.8 live load and 2.95 dead load, as dead. Okay. So 2.95, then we have 4.8. Okay, so that's clear. Then for the beam girder, so let's check the framing. The column is supporting 4 girders. So assuming tributary area, it will be 6 from here, 6, 6, 6. So it will be 4 times 6. The total length supported will be 4 times 6. Okay? 4 times 6. All right. Okay. Now, do we have walls here or direct load from the porta girder? So we don't have. So we can make this SDL 0. Okay, that's why it's 0. But for the self weight, we can go back to the beam tab and then get the equivalent load. It will be 16.8. So just put there 16.8. Okay, now this is the tricky part. So for initial sizing, the ideal is that the depth of the girder is equal to the size of the column. That's the ideal. So let's start with one by one, if it's workable. Okay, so concrete stress max is 15%. That's our target load. So meaning, we can reduce the size of the column or reduce the strength of the concrete. So I think the one by one is okay, it's workable. Or let's check what is the architect's assumption. You can check it in their CAD file. So let's check their assumption. Only 600. Okay. So let's try 600. But you might have a problem with the 600 because it might not support the girder anymore. You have a very big girder. Okay. So if you will use 600 by 600, our concrete strength should be 84 MPa, which is 10,000 psi. Oh, more than. It's 10,000 psi. Okay? So meaning, 600 by 600 is not workable. So as I mentioned, I think we can use 1 meter by 1 meter. Since this is just for initial assumption, I think this won't hurt much. Right? So let's try to reflect it here. So to verify it, we need to reflect it here. Let's see then 600. But when you draw it, should be 100 by 100. Then later. Okay, so let's check. Will affect if it will affecting a lot. Okay, so I think it will be affecting, but it is very limited because the distance is very far. Maybe this is no, this is tolerable. 1 meter by 1 meter, something like that. Okay, it's an increase of 200 each. Okay, now let's check. Let's start to reduce the what's the mean to get the 6. So what we can do to make it easier, so 0.007 times the concrete strength, maybe 5,000. Okay, 5,000 is working. 4,000. 4,000 is not. So maybe we can use 5,000 psi concrete. Okay. So doing that, can try. Okay, so what we can do is, we have now the size of the column, which is 1 by 1. Oh, sorry, we forgot to change the height. Sorry. Okay, so don't forget to change the height. So we need to check the elevation. The elevation is 6.2 and 3.7, 6.2. Right, sorry. Okay, so we need to check the elevation. So, but the elevation doesn't show the potential embedment of the footing. So we can assume that the footing will be around 3 meters lower than the NGL, since this is a 3-story. So 3 plus 3.7 plus 6.2. Okay, so let's put it here. So we have 3.9. Then we have 3.7. Then we have 6.2. Okay. So anyway, nothing changed. So still, we have the 1 by 1 meter column. And for the concept, and which is 5,000 MPa. Okay, so let's save it. Then we can now change the sizing. So we have here, we can put 1,000 by 1,000 columns. Then we have 700 by 1,000 girders. 700 by 1,000 beams. Okay. Then same thing here. So we put 1,000 by 1,000 columns. And 700 by 1,000 as girders. Then beams. 700 by 1,000. And let's go back to the ground floor. So we have 1,000 by 1,000 columns. Okay. So these sizes will be, I think it's good as initial. So this is just as mentioned, this is just the preliminary sizing or the concept sizing. Okay. Now, once you already finish the sizing, so at least we already have defined the concrete strength of the column. So we can now define the minimum concrete strength of the beams, which will be 35 over 1.4 or 4,000 psi. Okay. So we can use 4,000 psi for the beams and girders and the slabs. Okay. So for the last part, we need to size the footing. So basically, we just need to put here the soil bearing capacity. We can assume that the soil bearing capacity is 100 based on geotechnical report. Okay, so how to get this one, the soil bearing assumption. So we again open the geotechnical report from Brian Tan. Problem is that it's not that near, but at least we have an idea. Okay, so it's not the geotechnical report. Let's see what we need to check. This the other geotechnical report, the bore logs. Okay. So for the bore logs, we need to check what will be the layers, the initial layer of the boring. Okay, there's a lot of information here. Let's see what they have. Okay, grain size distribution, not that. The bore log. Okay, here's the bore log, the bore holes. Okay, so let's observe the bore holes. The top portion for the first 6 meters The dominant is the SM. Okay, SM, SM, SM. For these other boreholes, we have SM and CH. But for 3 to 4 meters, we still have SM. Okay, 3 to 4 meters, we still have SM. So SM means silty sand. Okay, now once you know the type, you have silty sand, and maybe we can check on the NSCP, National Code of the Philippines, to compare. Okay, you can compare to check the sizes. Okay, so let's open our NSCP. So we have NSCP na references, but I prefer to use my reference faster than to check on the internet. NSCP. So in chapter 3 of NSCP, we have a recommendation regarding how to determine the soil bearing capacity. Okay, so let's see. Still 207, 208, chapter 3. Here, lateral foundation, lateral pressure loads. Okay, we have a table like this, allowable foundation and lateral pressure loads. Okay, so we need to check where is the SM, right? We're here. So you can see silty sand. So silty sand has the allowable bearing pressure of 75. Okay, QA of 75. Okay, so let's put it here. We put 75 here. Initially, concrete strength, so we can make it just 3,000 psi initially. We can change it. Other factors, information, column 1,000 by 1,000. Thickness, okay, let's put it like that first. Then let's put the force. Here's the force that we need to design, 7.2. Okay, so we cannot paste directly. Okay. 7265. Let's put the 7265 kilonewton. Okay. Now let's go back to the provision. Given this 75, as advised by the code, is have a minimum width of 300 and a minimum depth of 300 to the grade national grade line. Except as noted in the footnote A, an increase of 20% is allowed for each 300 of width and or depth, to a maximum value of 3 times the designated value. An increase of 1/3 is permitted when using alternate load combinations in section 203.4 that includes wind or earthquake loads. Okay, so basically the 75 can still be increased by 3. Okay, just need to have a minimum width of 1,000. Okay, so since our width expected to be more than 1,000, then we can increase it by 3. The soil bearing capacity. Okay, so we can increase it by 3. Then let's use a factor of safety of 2. Okay, so we have 113 kPa assumed capacity. But still, it's not enough, no? So what we can do, we can reduce the thickness. I think this thickness is quite high. So this thickness, so we can use 500 as initial. Still, the size of coating should be increased. Okay. So to have an idea, we can make the initial manual calculation. Okay, so we can just divide this force. by 7265 divided by 113, then make a square root of it. Then we will have a size of 8 meters. Okay, we have a very big foundation as recommended by the geotech report, based on the geotechnical report. Okay, let's go back to the foundation. Maybe we have another, we might have other. Okay, so let's proceed. So we will be needing around 8 by 8. Okay, we still need to increase the size of footing despite it's already 8 by 8. It's like it's very heavy. Okay, it's already like a mat foundation. So maybe what we can do is to dig deeper, go deeper. Okay, deeper in the strata. Okay, because we are only at the SM level. So maybe CH and CL, let's check CH and CL, silty clay, CM sandy clay. So let's check in the NCP if it will produce a higher. No, it's actually it's a poor. It's not a good soil at all. Okay, so since with the lack of the reports, soil reports, so we need to assume for now. So the second layer is the CL, which is not a good soil, as we saw. Okay, so the best option is still to stay at SM, sandy, silty sand. Okay, so I think we still need to work this out. We need to increase even the thickness. So it's like it will just fail and fail and fail for our load. Maybe we need to increase maybe 9 by 9. Okay, so 9 by 9 is enough, but it's failing in the shear. So we need to increase the shear. So what will happen is like a 12 by 12. It's very big. It's very big already. Okay, so for the foundation, initially we can put just to make it safe. But we will, for the SD1, we will study the use of, we need to study the use of we need to study the use of piles. I think the piles will be a lot cheaper by that time. Okay, so we can reduce the one, two. Okay, so very near to share. One. So bearing, this very small. Okay, so at least we can use a 9 by 9 by 1.1 thick foundation. Okay, so let's reflect it. Let's generate the first. But we need to study, once we go to the SD1, we need to study if this foundation type is more economical than using piles. Maybe piles is already cheaper. Okay, especially board piles wherein we can directly put the columns. Maybe it might be cheaper, or maybe we can use the push piles. Okay, so let's go back to the schematic. So ground floor layout. Okay, so we need another copy of the foundation plan. Better, we will create. Sorry. So I will copy again another ground floor since it's supporting ground floor. Put it in the concept plan. So just see what we can do is to copy it here. Sorry. It's D1, then inside the concept plan, we need to create another copy of plan, and then let's name it as foundation layout. Okay, so let's crop it, bring it to the concept plan folder. Let's open. So for the foundation layout, we need to make sure that we have the, let's copy the one in the ground, the columns. Actually, it's just the columns. Okay, then we paste it here. Exact. So now we will lay out the footing. Okay, since the footing is too big, maybe we can create another one. It's like two footings, one here and then one on the other side. Or because this definitely, if it's a 9 by 9, then we will be going here, right? So that's another option. You can do another column. Just copy it. But we will not change the size of column, only the size of foundation. Okay, so for the side, for example, so since the 6 meter span is all at the edges, so the span will be 6 by 3 by this one, 12. That's the largest. So 3 by 12. Use this one, 3 by 12. There's a huge difference for sure. Same SW, same SDL. Then for the girder supported, it will be only 12. 2 times 6. Okay. Then we don't need 1 by 1, so maybe we might need smaller. 600 by 600. Okay. This might work. Just stay 1 by 1. Since we will not change column, I think we can stick to the 1 by 1 for now, for the concept plan. So uniformity. Then we will have a cumulative load of this, very small. Okay, so we make another footing. Let's copy the footing template. And footing, so we can name this one as perimeter or smaller. Then the other one will be the 12 by 12, 12 by 12 footing. Can put this one as 6 by 12 footing. Okay, then we can copy the force 2, 3, 6, 7. Let's put it there. 2, 3, 6, 7. So definitely it won't need that big, that size, right? So we have almost half, so we can just make it 6 by 6 maybe. 6 by 6. And then we can reduce it to 600 or 500. Let's check. Still passing, it's still big, so we can make it 5 by 5. 5 by 5. 5 by 5 is already good. 5 by 5 by 500. So let's say. So we have two sizes of footings. We have a 9 by 9 by 1.1, and then we have 5 by 5 by 5. Okay, so let's plot it in the foundation. So we can copy this one. So we can copy this one and this one. Okay, so just put there foundation framing or foundation concept. Yeah. Then we have two sizes, so we need to pick colors. Maybe orange. Two shades of orange will do. Dark orange, and then this is for the big one, 9 by 9 by 1 1. And then the other one will be the lighter yellow, the lighter orange. Okay, so this will be 5 by 5 by 500. Okay, so that's the huge discrepancy. That's a huge difference. Okay, so okay, we can move it somewhere here. Okay, so save. Then let's plot. With the square, then the color should be orange. Okay, so you can put it just a representative. So this one is a 4.5, 2.5, and 4.5 will overlap. Okay, so maybe this is the approximate distance. Then it will just be copied. So should be square. So 4.56 will be somewhere here. 6 here. 6 6. So it's a top 9 by 9. Let's copy. This one and this one. Something like this. Okay, so let's copy. Okay, then we have the smaller ones. 5 by 5 only. So we can color it once. This is too dark. Maybe we can change the color. It's not good to see this kind of color. It's so strong. Okay. So here. Title one. Okay. Layer. Okay. Then they have the yellow orange. Change this one. And then so just copy it. And then distribute it to the perimeters. Okay. By the way, this is not scaled, so you don't need to do something. Just project it. Then this one you can just copy. Put it there. So it's almost complete. Okay, so for this one, since it's complex, maybe we can copy this one. Then have them together. All of them. So this will be the foundation concept. Okay, so we're done for the plans. Now we need to create the schematic or the concept section. It's the last part. So let's check if we already have a section in the architectural plan. So we don't have, we need to print one. This is it. Okay, so delete this one because we're not using steel beams. So clear this one. It's okay. RC steel decking, clear this one. RC, clear this one. RC column. Let's clear it. Okay, then let's try to plot. Biggest possible. Okay, so is this the biggest possible? Maybe not. No, it's because of the shape. Okay, maybe we don't need to. Let's bring the grid lines down. So as this measurement. Okay, and let's see again. No, so there's nothing I can do. It's really something like this only. Then you save, put it in the desktop. So concept section. Okay, the concept section. So we need to provide the columns. So what is the color of the column? So it's black. So just put black. Black. Here. Okay, so columns will be up to this level only. Multiply always. Okay. So these columns. And then we have the beam. Okay. The beam color is blue. So we need to make it blue. And the size now. Something like that. So here. Sorry. Forgot to extend. So we have to do it this. It's better. We'll just delete. So that's what I'm talking about now. So this revision, effective work, functionality, a lot of time. Okay. So let's just quickly copy it, paste it. Here and there. Okay. So we have this 3 layers of your layers. And you can copy it. Okay. Then, copy one so that we can just resize. Okay. Okay. So we have a clear idea that we will be using columns, headers, and then we need to provide the footing. So earlier, we have two footings. The color should be consistent, as I mentioned. So we have to have footing like this. So it's quite smaller. So maybe we can do something like that. And then we can copy it to the other side. Okay, that's here. Now for the other one, let's copy, just make it bigger, because it is bigger. Okay. So I need something like this, then change the color. Okay, then we have, and just copy it here. Okay, and we're done. Now what's missing? You just need to put the sizes. Okay, so we need to get this. Put it in the foundation here. Put it in the concept section, something like that. And then you can find the foundation. So we're almost done. And then that's a final touch, and then that's done. That's it. And just to save. And we're okay now. We're still missing the embedment. So we need to put this distance. Okay. Remember, we assume it to be 3 meters from MGL. Maybe we can assume it 3 meters. Okay. Or it will be 1.1, thickness 1.1, then 3, so 4 minus 1.1. Let's try the calculator. So 3 meters, then 4 meters from the ground. So our measurements from the ground is here. Just put some lines. This window. Always okay. Then change the font size. Okay. Always make it presentable. Make sure that your output is presentable, else no one will read it. Okay, so that's it. 3.1 meter. So let's copy this one. We know what we consider. Okay. So that's it. Change this one to black, and then point one. Right? Okay. So that's it. That's the concept plan. So I hope this video can help you while doing the step-by-step concept plan. As you can see, you can finish the concept plan in less than a day. For structures like this, maybe up to 10 floors. But for very high structures, maybe we cannot do it that much. Okay? So that completes the procedure in doing the concept plan. And next thing that we will do is the formally establishing of design criteria. Okay? Thank you and bye-bye.